The topic of this video is A-static algorithm. So as we have previously studied BFS, DFS, and greedy best first search algorithm, we have seen that these techniques consider different approaches. And in our A-static algorithm, what is different? Basically, A-static algorithm is a type of informed search technique. By informed search technique, I mean that we have some prior knowledge and we are going to use some heuristic function, some evaluation function, and based on that evaluation function, we are going to reach our goal. So in our greedy best first search algorithm, we were only considering the heuristic cost that is from our current node till our goal node. Consider this A as our current node and G as our goal node. We were only considering the heuristic cost that is, let's suppose 20 is required from this node till this node, and every next node has a heuristic cost. And we were basically using a greedy approach, selecting the minimum cost, a heuristic cost only. A-static algorithm is different as it considers not only this heuristic cost, but also considers actual cost that is required from moving from A till B. Let's suppose that moving from A to B requires a cost of 10 and moving from A to C requires a cost of 3. So A-static algorithms guarantees you that it will give you shortest path from your starting node till your goal node. The function that it uses is f of n equals to g of n plus h of n. H of n is the cheapest path or the shortest distance from your node till your goal node. The heuristic cost, in other words, that is given in our questions, that is A equals to 20. This is the cost that is required from moving from A till goal node. The other cost that is considered is G of n. G of n is the cost that is between these nodes. So it's also called as actual cost as well. Now let's take an example. It will help us understand further. And for this, we are going to see code first. So this is the code. In this code, as previously I have explained this, that Karachi is connected to Islamabad and Faisalabad and so on. You have to make a graph of this. And in this graph, also there are some distance, some cost mentioned here. From Karachi till Lahore, the actual cost required is 1,000. And from Karachi till Faisalabad, the cost required is 800. Similarly, from Faisalabad to Karachi, the cost is 800 because it's two-way. So from Peshawar till Islamabad, the cost required is 180. From Peshawar till Quetta, the cost required is 450. This is the distance between the nodes. And then we have heuristic cost. So from this code, you can see that for Quetta, it's mentioned as 0. Heuristic cost is 0. This means that Quetta is our goal node. And Karachi, in this scenario, is our initial node. It can be different. It can be Islamabad. Why it can be different? Because this is the cost, heuristic cost that is required from moving from Karachi to Quetta. 600 is the heuristic cost that is required. Similarly, from moving from Peshawar till Quetta, the heuristic cost required is 400. And similarly, from moving from Multan till Quetta, the heuristic cost required is 350. So now let's check a graph. Here I have made a graph, and the heuristic cost is mentioned here, and the actual cost is mentioned here. So A-static basically guarantees you the shortest path. And if we need to calculate this, G of n plus H of n, this is the distance between the nodes. And this is the heuristic of the node which we are currently moving to. Let me explain. If I'm moving from Karachi to Lahore, my first cost that is between these two nodes is 1,000. And my currently my goal node is what? Lahore. So heuristic of this will be considered. And the heuristic of this is 550, sorry. So 1550 is the basically is the cost that is required from moving from Karachi to Lahore. Similarly, if I'm moving from Karachi to Faisalabad, the cost that is required is 800 and plus the heuristic cost of Faisalabad, because this is my goal currently, it is 500. It gives 1,300, which as compared to 1550 is lower. So let's expand it further. Apologize for this. I'm moving from Karachi till Faisalabad till Multan. Now, Multan is my goal node. G of n will be 800 plus 400, this, and plus H of n of Multan, because Multan is my goal node. So it will be 350. So it basically gives 1550, which is equivalent to this cost. So these two costs are now in a competition because these two are equivalent. So if I expand it further from Karachi, Faisalabad, Multan, and Multan is connected to Lahore. So if I add the values here, 400 plus 350 plus now heuristic cost of Lahore, that is 550, it gives a total of 2100. So 2100 is greater as compared to this distance, that is Karachi till Lahore. So this basically wins and this basically loses. Let's expand Karachi Lahore further and solve it further. From Karachi Lahore Islamabad, the values will be 1000 plus 300 plus my goal is Islamabad. So Islamabad heuristic cost is 450. It adds up to 1750. And from Karachi, Lahore, Islamabad, Peshawar, I have a total cost of 1000 plus 350 plus 300 plus 180 plus 400 is the heuristic cost of Peshawar. And if I add these values, it gives, it gives 80 plus 450 plus 0, because 0 is the cost that is required because it is the goal node and 0 is the heuristic cost of it. So the total becomes 30. This is our shortest path from Karachi till Quetta. I will explain this further in the second half of this video using code. If I run this code, so you can see here from Karachi, Lahore, Islamabad, Peshawar, and Quetta, the total cost that is 1930.